This tutorial will cover the conversion of raw fMRI images from your scanner into a format that can be read by your software analysis package. Images come directly off the scanner in a variety of formats depending on the type of scanner and the manufacturer. For example, Siemens scanners output a format called dcm, whereas a Philips scanner outputs a format called par-rec. The goal of conversion is to convert these raw fMRI images into a format that can be read and understood by different fMRI analysis software packages. One of the most common standards for fMRI data analysis is a format called NIfTI, which stands for Neuroinformatics Technology Initiative. Images with this format have a .nii extension to them, and they have the advantage of being able to be read across several platforms, such as SPM, FSL, and AFNI. The first thing to do is to find a suitable conversion program. The one recommended by FSL is a program called MRIcron. Just type MRIcron into Google and type on the first result that comes up. MRIcron is a suite of packages which includes a converter called dcm2nii, which stands for dicom to NIfTI. In order to install dicom to NIfTI and the rest of the tools in MRIcron, just click on the installation link and follow the instructions according to your computer platform. Once you're done downloading and installing MRIcron, go ahead and look for the dcm2nii GUI program. Dicom to NIfTI is a very simple interface and it's very easy to use. The first thing to notice here is this drop-down menu, which allows you to specify the output format that you want your files in. Besides NIfTI, there's another format called header/image, but we're going to focus on NIfTI for now. This option, compressed FSL 40 NIfTI, will output NIfTI files and also compress them in order to save disk space. So let's go ahead and select that for now. One more thing you might want to check is under the Help and Preferences options, you're able to specify what information you want prepended to your NIfTI files. Most of these you don't need. And you see an example of the output file right here. This looks rather long and unwieldy. Go ahead and uncheck everything except for acquisition series. This makes the resulting output files much easier to read. Now that we have dicom to NIfTI set up, all we need is some raw fMRI data to convert. I've provided some on my webpage, which is mypage.iu/AJAHN. Go to the links and click on FSL example data to download a sample data suite. I've already downloaded it to my desktop right here, so let's go ahead and see what's inside. You can see we have a few different directories and a couple of different scripts, which we'll focus on later. For now, look within the fMRI_raw data directory. You can see that we have hundreds of dicom images here. Another important thing to note within this folder is this text file called scanning parameters. This gives information about each run. In this experiment, what happened was we had a device next to a subject's head, which is my head, and we wanted to see whether it would produce any artifacts. So the parameters here are there are 165 volumes for each functional runs, with 35 slices in the z direction, and a TR of 2 seconds. The anatomical scans have 160 slices. For now, the only runs I've provided for you are runs 5 through 7. This is a very simple task where I just did tapping my right hand, tapping my left hand, and then holding my breath and also exhaling. So, if we go back to here, we know from the text file that the functional scans begin at run 5. The second column here tells you what run you're at, and the third column tells you what image is being acquired. So here we see the start of run 5, and if we keep scrolling down, it should end at 165 volumes, and it does. Run 6 is the same, and when we get to run 7, it should end at 160 volumes because it is an anatomical run. And we see that that is also what happens. It's good to check for this just to make sure that there are no runs or volumes that are missing. Once we're done with that, we can select any of these images, literally any one of them, and click and drag it over to this icon, the dcm2nii GUI icon, in the dock, and release it. It'll start converting. The conversion for very large data sets can take up to several minutes, so be patient. After dcm2nii has finished converting, you'll see the conversion completed at the end of the text box. Let's go back to the fMRI_raw data directory and look at what's been produced. Now we have NIfTY files which have been converted from the DICOM files. The ones we're going to focus on in the future tutorials are 5, 6, and 7. The rest of these represent either redundant scans or images of the anatomical scan, or things like the scout scans, turboflash, and field mapping scans. For now, we're not going to focus on those, so we can go ahead and delete them. After you're done, you can use this to then convert all your other DICOM files for your other data sets.